This is the ambiguous case part 1. In this clip I'm going to demonstrate the side-side angle case and why it's the ambiguous case and how 0, 1, or 2 triangles can be created when you have two sides in an angle. I'm going to do that by solving 3 different triangles and trying to demonstrate the 3 different cases that could happen. First, in this case, we're given the information in red that 50 degrees is the angle, 4 and 3 are the sides. And I'm going to try to show you why this triangle doesn't exist. First, let's determine the height. The height of this triangle is equal to 4 times the sine of 50 degrees, which is approximately 3.06. As you can see, the height is bigger than this side, and this side here and this angle here are free and cannot move. Let's see what happens. This is the same triangle. Notice there's BD. There should be a ray or side here. Watch what happens when I try to bring this 3 down to make a triangle. Notice that the height is 3.06 and the side isn't going to reach. You can see that C is less than D, slightly less, 3 and 3.06. It's not going to make a triangle. So what is the condition which creates, or what's the situation that creates 0? Thus, as you can see, when this side is less than the height, there's going to be 0 triangles. So that's the first case. Now let's demonstrate or show you the situations or the conditions where you get 1 triangle. In the second situation, you can see I just changed the sides 3 and 4. This totally changes the situation because the height is now changed, and the height now becomes, let me move that in there, the height now becomes 3 times the sine of 50. Now notice that's about 2.29, and this side, which we can move because this angle is not fixed up here, is now bigger than 2.29. Let's observe what that looks like in this script. I tried to get as close as I could to having 3 of 50 degrees and then 4. Watch what happens when I move this side down. You can see now, I didn't intend to change the angle, but you can see I'm trying to get close to 50 and 3. As I move this side down, you see there's the triangle that's formed. Notice that it's bigger than the height, but it's also going to sweep past here. So the only triangle that exists is this triangle. And once you know there's 1 triangle, you can easily use the law signs like you've been doing to solve this situation. Now let's take a look and see what happens when we have a 2 triangle situation, or the conditions that create 2 triangles. Before I move on to the 2 triangle situation, let's summarize what we learned about 1 triangle. What creates 1 triangle is when, well, there's 2 situations that can occur. If this side is equal to the height, then you have a right triangle, and there's therefore 1 triangle. But what we just learned is if this side is bigger than both the height and this third side, it also could be equal to this third side, you're going to have 1 triangle. So that's the summary there. Now let's move on to 2 triangles. I'm now going to make this third side a measurement that would create 2 triangles. So first let's wrap up what we did before. If this side, the height still is 2.29, if this side is bigger than the height and the third side, like in the previous problem it was 4, if we make it 5, if we make it 6, that's going to create 1 triangle. And if we make it anything less than 2.29, it's going to be no triangles. Like if this side's 1, or that is this side is actually 2, there will be no triangles. Let's put in a number that's in between the height and the third side, and let's demonstrate why that would create 2 triangle situation. So here we have 2.5. It's certainly bigger than the height, so the triangle exists. What makes it create 2 triangles? What happens there? Let's go back to the script, and you can play around with this on the web page if you'd like. Here is the situation as best as I could get it. This is a 49.9 degrees instead of 50, and that's 2.98. But here's the 2.5 side. Let's swing it down and see where the 2 triangles come from. First, the triangle that most of you will get with the law of sines is this one. But notice that I can bring it past the height, and since it's less than the third side, you can see there is the second triangle right here. So there is 2 triangles that are created with this situation. And to summarize it, if this side here that's moving, in this case 2.5, is bigger than the height and less than the third side, it's going to be able to swing around and create two triangles. It looks like here's an obtuse triangle with a 50, 2, 3, and 2.5. And then over here, an acute triangle with 50, 3, and 2.5. Let's summarize this, what creates two triangles, in a summary. You get two triangles when this side that could be moving, because this angle is locked, is bigger than the height and then less than that third side. In the second clip, what I'll do is demonstrate how you get those two triangles. Everybody's going to be able to get the one triangle using the law of sines when the one triangle situation exists. And now you'll know by the test, if you test for 0 triangles, you won't have to do anything. Just calculate the height and compare that to this side here. So in the second clip, I'll demonstrate the two triangle situation and how you find those two